Chinmaya for this meeting. Over to Mark to introduce Mr. Chinmaya.
Okay, friends, welcome. Good evening. Good evening to all. This webinar on war submarine will be lectured by my friend, 1981 mechanical batchmate, Commander Chinnaya. He is from Thittakudi near Todudur and that area. And from the college itself, during the campus interview itself, he got selected. And in our batch, there were 3 service personnel, 2 for Navy and 1 in Air Force. And one is Commander Chinnaya. He opted for submarine and lived most of his life in submarine and in Vizag. And he continued to live in Vizag. Another person is Rear Admiral Nedunjeliyan. He now retired and living in Chennai. And another person is Air Commodore Soundararajan. He is now retired and living in Coimbatore. And Chinnaya, I requested him to give this lecture because many of our civilian people like us may not be getting a chance of seeing a submarine or how they live and how the submarine is going down the sea surface level. All these things, no, it will be very interesting to know from the person who lived in the submarine. And Chinnaya, after his naval service, he joined with L&T. He joined with then after serving for 5 years, he joined in Hindustan Shipyard, and now he is retired. And in a short stint, he spent his time in giving lectures, technical lectures for the students of Maritime University there. And now he is spending his time in gardening and organic farming, because many of our people know that in 81 batch, 15 people of our batchmates were running an organic farm in Bandavasi. He is one among them. And he spends a lot of time in Bharati Tamil Kalai Mandram in Vizag. He is a secretary there, and he's having a lot of passion and interested in singing too. And he's very fond of maintaining a beautiful forest-like terrace garden in his home. His wife is Dr. K. Jayanti, pediatrician. Both are living, and both his sons are abroad. One is the elder one is a doctor living in Australia. Younger one is in UK and US shuttling. He's a mechanical engineer, got a master's from IIT Goa. Okay. Now Chinnaya will be explaining about all his life and thrilling experiences, as well as the technical aspects of a submarine to all of us. And people are requested to join, and this will be a rare opportunity to get it. Okay. Thank you. Welcome, Chinnaya.
Thank you. So, may I start?
The session is live in Facebook group. Facebook group name is Technical Lecture Live Stream. That can be saved later also.
நான் ஆரம்பிக்கலாமாங்க?
Okay, ஆரம்பிக்கலாம்.
அனைவருக்கும் அன்பு வணக்கங்கள். என்னை பத்தி சொல்லிட்டாங்க. எனக்கு கொடுத்த லெக்சர் டாபிக் லைஃப் ஆன் போர்ட் ஏ வார் சப்மரைன். லைஃப் ஆன் போர்ட் ஏ வார் சப்மரைன். லைஃப் இஸ் ஸ்மால் பட் சப்மரைன் இஸ் வெரி பிக். அதனால நான் சப்மரைன் பத்தி நிறைய பேசுவேன், லைஃப் பத்தி கொஞ்சமா பேசுவேன். நான் பேசுறதுக்கு முன்னாடி வின்ஸ்டன் சர்ச்சில் என்ன பேசியிருக்காருன்னு பாருங்க. Of all the branches of men in the forces, there is no forces which shows more devotion. அது ஒரு பாட்டு. Second part is, and faces grimmer peril than the submariners. We face griller perils perils in our life on board always. So that will briefly tell you, how will be a life on board submarine. என்னுடைய presentation நான் இந்த டாபிக்ஸ்ல கவர் பண்ணுவேன். Submarine is a vessel which can maneuver underwater. Okay, it can maneuver on surface also. அதே மாதிரி சப்மரைன் சப்மர்சிபிள் நிறைய கேள்விப்பட்டிருக்கீங்க. சப்மரைன் இஸ் ஆல்சோ a submarine, but it has got limited underwater capabilities that is used for civilian application. With submersibles are used for civilian application and non-combatant military purpose also. And this submersible always work with surface ships. It cannot go independently, unlike a submarine. There's something called midget submarines or mini submarines. These submarines are ones with less than 150 tons weight. Okay, these submarines, mini submarines or midget submarines, are operated by a smaller crew, one or two, at the maximum 9 or 10. Okay, and these midget submarines don't have any living onboard the vessel. And these midget submarines also always work with the motherships or mother submarines, and they are launched, operations done, and recovered back. And there's something called wet submarine. Wet submarine is nothing but underwater bikes, and here the operator gets exposed to the seawater directly. Of course, he will be with his scuba diving. And what are the purposes and uses of submarines? Where we use this. Submarines are used to patrol the seas and oceans. While doing so, they gather intelligence, undertake surveillance, and carry out reconnaissance missions. They observe closely or they observe generally. And when they identify a target, they follow the target and monitor its activities. When we are closer to the land, enemy land, or hostile regions, we can land our special forces like the Marcos, they will be landed. And at war, they can enter into the enemy water very closer to the harbor. Okay, like in 1971 war, it was just one of our submarine was just outside Karachi harbor and bombed the harbor, and they could see the Karachi burning. Okay, from the submarine, they can so go so close and launch missiles or torpedoes on the enemy targets either on land or on the sea. Also, this is used as submarines are used as missile launch platforms. Missiles are the deadly weapons, you all know, and with this can be done hiding yourself. So it will be a great surprise for the enemy because it'll not be an easy show for him, for the enemy. With this feature and abilities, submarines are force multipliers. What is force multiplier? Like in movies, you see when an ordinary fellow goes, he gets bashed up by one or two fellows. But when a hero goes, he gets, he handles, or to handle the hero, the 40, 50 chaps, depending upon the hero, whoever is the hero, that many number of people will come. If it is Rajinikanth, it may be even 100 people coming and attacking. See, he is a force multiplier. Like that, submarine is a force multiplier. If a aircraft ship is sighted, one helicopter itself may be enough. But if there is a submarine at sea and enemy feels there is something there at sea, there will be multiple. A fleet of ships will have to come to handle such submarine. So submarine is a force multiplier. Submarines are used for non-military purposes also, and I have listed some of them. What is the principle of operation of submarine? It's work on the Archimedes principle. You all know Archimedes principle. When a submarine is either, when a vessel is either, when a body, ship or submarine is either floating or underwater, there will be a buoyant force acting on it. The buoyant force will act at the center of gravity of the volume of water displaced, and the magnitude of the buoyant force will be equal to the weight of volume displaced by that body. Okay, this is a basic principle with which the submarine operate. And to do all the operations purposes VOC, what do we need? Okay. Before going into that detail, I like to show a small video if it gets played. Okay.
If the embedded file is not working, you can play directly from the computer, sir.
The video visible இல்ல.
Oh, I'm sorry.
திரும்ப இந்த வீடியோ ஆப்ஷன்
I was sharing it, you know.
Yeah.
இப்போ
Sharing with audio and video. Sharing PPT along with audio and video option.
Okay, share screen. Oh, share sound and optimize audio. I'm sorry, you told me before.
Yeah.
My mistake.
Good morning.
Again share screen.
Share screen. Share.
டிசம்பர்ல வந்து 2 months ஆச்சு.
A submarine has a sleek cigar-shaped body that enables it to move swiftly underwater. A pressure hull made of high-strength metal contains the submarine's crew, machinery, and most or all weapons, preventing them from being crushed by the pressure of the water at deep depth.
Okay.
A submarine has tanks built into the bow and stern called the main ballast tanks. The sections of the bow and stern containing the tanks are not usually surrounded by a pressure hull. In order for the submarine...
Okay.
A submarine has a sleek cigar-shaped body that enables it to move swiftly underwater. A pressure hull made of high-strength metal contains the submarine's crew, machinery, and most or all weapons, preventing them from being crushed by the pressure of the water at deep depth. A submarine has tanks built into the bow and stern called the main ballast tanks. The sections of the bow and stern containing the tanks are not usually surrounded by a pressure hull. In order for the submarine to dive, the main ballast tanks are flooded with seawater. The added weight causes the ship to lose its ability to stay on the surface of the water, and it submerges. Movable surfaces on the outside of the submarine control its movement beneath the water. These surfaces are horizontal diving planes and vertical rudders at the stern, and a forward set of diving planes either on the bow or on the sail structure. To dive, the diving planes at the stern are tilted down. As the submarine is propelled forward, the flow of water over the tilted planes causes the submarine to glide downward. The rudders steer the ship. Crewmen can turn a rudder to the left or right to make the submarine change course. To move the submarine upward, the stern diving planes are angled up. The diving planes at the bow or sail are used to help keep the submarine at a precise depth while near the surface, especially when launching missiles or when raising an antenna or periscope above the surface. To resurface, water is blown out of the ballast tanks by compressed air so that the submarine comes up through the water.
Is the screen visible now?
Yes, yes, yes.
Yes, visible.
Yeah, to do all the requirements, to meet all the requirements, we need so many systems. These are all, all there in the ships also, but the characteristic or specifications will be different from the ship. And there are some items which may not be there in any ship, but it is required in the submarine. Okay, we will see them one by one. Like this is the pressure hull. We have pressure hull and outer hull. This is the outer body of the submarine. This is outer body of the submarine. And inside that body, we have this pressure hull. Okay, and the pressure hull helps us to run deep and run silent. And this pressure hull is supposed to withstand the hydrostatic pressure, which is huge depending upon the depth. This is a cross section of a submarine which is under construction. This is called, the submarines are constructed with modular constructions. They are constructed in sections. Okay, this is one of the sections. And you see this red line all around is the pressure hull, and the outer line starting with the green. This is the pressure hull, and this is the outer hull, or we call it as external hull also. Okay, what is there between the pressure hull, that is the inner hull, and outer hull, we will see in the course of time. Pressure hull bears the maximum load in the submarine, and hydrostatically at 110 meters, the body will face 1 kilogram force, 1 atmospheric pressure. And if it is at 300 meters, there will be 30 kgs. So the pressure hull should be designed to overcome this enormous pressure. Underwater, the pressure has, inside the pressure hull where human beings are working, is normal atmospheric pressure. This will enable human beings to operate this submarine. And the hull, I have two designs. One is single hull submarine and the other one is double hull submarine. Americans use a single hull submarine. Single hull in the sense, the hull will be at majority portion, especially on the center portion of the submarine. This will be exposed to the seawater. Of course, at the end, we will have streamlined structure to enable a smooth flow and less noise. Okay, and that space is used as main ballast tanks. Okay, and the outer hull, Russians use the double hull structures. And what is outer hull? Outer hull is the surface or boundary of the submarine, which is the outer boundary of the submarine. Okay, this outer hull need not withstand the hydrostatic pressure when it undergoes, because this complete area is free flooded. Means there will be seawater inside at the same pressure outside. So the pressure difference between any place, between the this thing will be same. The pressure difference is almost zero. Okay, the pressure hull material is a high strength alloy steel, low alloy steel. Okay, this high tensile strength, good toughness and resistance to corrosion, and the ability to withstand the structural integrity at high pressure are very essential for these materials.
Audio not coming.
Is it coming now?
Yeah, it was okay. It's okay.
Okay.
Okay, maybe in certain sections. Okay, the outer hull, the pressure hull, in addition to the heavy thickness of about 20 to 25 mm, it will have to be strengthened because some compressive loads will be acting underwater. The compressive load will have the tendency to crush it. To hold that, we have something called reinforced rings or frames. That will be around the pressure hull all along the length of the submarine. Okay, this is transversely framed design, and all submarines have followed this design. And this is a submarine museum somewhere. And if you see, this is the total thing is the hull of the submarine. Okay, partly pressure hull and partly outer hull. And the center portion, you see some tall structure. This is called a fin. See here also you can see this. This is the fin of the submarine, and you have entry into the fin through the side, one of the side, and you see people on top also. Okay, and there is something called conning tower. The conning tower is inside the fin. The conning tower is a sort of transiting station, like inside from inside the pressure hull to come out of the submarine, out of the pressure hull. We use this conning tower. Conning tower in modern design, they are of small this proportion, but in the olden submarine, it will be as good as 2/3 of the conning tower will be 2/3 of the fin will be conning tower, and they houses the many control equipments and the sonar, radar, electronic warfare, and things like that. That's why it's called a control or conning tower. Nowadays, all of them are inside the pressure hull, and the conning tower is small. The conning tower is also used as a escape method. It helps us to escape from the sunken submarine. And on top of the fin, you will find, there will be a platform at this level. And that platform will have, you can stand on the platform, and there will be an opening on top of the fin where the surface watchkeepers will stand. Okay, will stand and observe the submarine. In the surface, the bridge is almost the control station of the submarine. And this is very rarely used while entering and leaving the harbor only. We use the bridge. Otherwise, we are always underwater. Okay, we have seen about the main ballast tanks. What is a ballast? Ballast is any substance that increases the weight of the marine crafts or the hot air balloons to make it stable. The process of increasing the weight is called ballasting, and submarine with a positive buoyancy floats on the submarine. To take it down below, we need to add ballast. We cannot bring heavy weights and load the submarine just before diving. So we use water, seawater, to flood these main ballast tanks to get into the submarine into the water. Submarine inside the water, when it is normally floating, it will have a neutral buoyancy. And that time, if we have seen, the weight is equal to the amount of water it displaces. Okay, at that space, it will not dive, it will not go down and it will not come up. If you have to float the submarine, again, you have to bring the positive buoyancy. For that, we use high pressure air to force the seawater out. This is a cross-sectional view. See, this is where the seawater enters. See, normally when the submarine is floating, it will be at this level. Okay, there will be some pressure acting on the water to enter into the submarine, and we use the vents. When the vent is opened, this is a vent is opened, but water rushes into this tank, and as it enters, it becomes heavier and the submarine goes down. While coming up, we use this passage, let high pressure air, as good as 400 kgs of air is let into the tank to push the water and kill the negative buoyancy and gain the positive buoyancy and to come up. And these tanks underwater, as I told you earlier, will not have high pressure, will not be acting on the plating, because pressure inside the volume and outside the volume will be same. And of course, the pressure inside pressure hull will be a normal pressure. Okay, in addition to the ballast tank, we have got variable ballast tanks also. These variable ballast tanks are used to correct the weight underwater, because weight will not be same always. Like when you enter, you will have 30 tons of fresh water. When you come back to the submarine, come back to harbor, you will have just hardly half tons or 1 ton of fresh water. That much weight goes out from the submarine. To compensate that, we need some place to take it. Also, when you go down from the surface into the sea, into underwater, you need to break the surface resistance. So you have to be extra heavier. That extra heavy water is taken into the depth control tank or compensating tank. It goes inside, then we pump out. As we slowly consume the ration, or as we slowly consume the fuel or any other items, even the dresses we use are thrown out into the sea. Okay, the weight reduces. That time we take water to compensate the weight of the submarine. And there's some, this is called the depth control tank or compensating tanks. And we use, that is compensating tanks is to control the submarine in its vertical plane. And in the horizontal plane, if you have problems, that is if the bow is down or if the tail is down, we have to correct it. That time, like a seesaw, we adjust the weight from the forward trim tank to aft trim tank, or from the aft trim tank to forward trim tank. This water is transferred very fast. We use pneumatics for this. Means we pressurize one tank, and when the other tank, water gets transferred either from here to here or here to here. Very fast action is taking place. And we carry torpedoes. As soon as the torpedo is fired, the water is drained into that, if into the tanks. That time there will be trim disturbances, so we use, the water is collected in the water around torpedo tubes. And the torpedo operating tanks are to compensate the total loss of the weight compared to while entering harbor and while coming back to harbor. We may go out with 15 torpedoes. While come back, we may come with nil torpedo. Okay, so 30 tons of weight is to be balanced. That is balanced in the torpedo operating tanks. And we have something called the quick diving tank, which is also a ballast tank. Quick diving tank is used to dive fast. In the normal submarine, we use the normal procedure to go down, but at war time or during operations, important operations, we have to flood this Q tank, which makes the submarine very heavy in no time. And as soon as we go down, when we stabilize, we blow out the tank. It can be blown out or it is pumped out. And next is, in the video also we have seen, to maintain the submarine in the horizontal plane, we have to use the planes, hydroplanes. Hydroplanes help us, like the fins of the wings of the aircrafts. Hydroplanes help us to fly through the boat, fly the boat through the water. These are called either bow planes or off planes. And also these ones are called off planes or stern plane. For bow planes, so Americans call it as sail planes or forward plane, and this one are called stern planes or off planes. Okay. This is a closer view. This is the plane. Say this is a forward plane. This is the bow of the submarine. The tail is behind. It is hinged in the forward side of the submarine, means in the forward side of the plane. So this portion, the trailing edge of the plane, can go up or come down, operated hydraulically, and force acting on it when the submarine flows with the speed. When it is raised, force will be acting on it, depending upon whether it has to go up or come down. We adjust the position and the submarine goes down. This is used while diving. You have to control it. Also underwater, there will be disturbances always. How do we adjust it? That we adjust this with this plane. Like for example, there will be a TV screen played in the forward side, and 20-30 guys will come inside. Weight may go up by 15-20 tons. Okay, sorry, 1.5 or 2 tons. Those type of minor adjustments are done with this forward planes and off plane. Even immediately after firing the torpedo also, there could be disturbances in the submarine position, and we need to control it. We control it by planes. This is off plane. Off plane also, in the forward leading phase, it's hinged, and off edge goes up and come down. These are the rudder. Rudder are to steer the submarine in a horizontal plane. Turn to left or right, means turn to port or starboard side. We use this we use the rudder. And these are all operated hydraulically, and there will be secondary mechanisms. Electrically also they can be operated in emergency. And how do we get power? We use the diesel generators in conventional submarines, and in nuclear submarines we use steam generator to get the power. And when underwater, we cannot run the diesel engines or diesel alternator because you need air. Okay, that time we use power from the batteries. Okay, they give the life or movement to the submarine, light and movement to the submarine, and to operate all the equipments. In nuclear submarines, you don't have that problem because reactors can operate underwater also, and that's why we use nuclear submarine in large number. And the submarines, endurance of the diesel submarine underwater depends upon the capacity of the battery and utilization of the power. Like the mobile, when you are traveling in a train, okay, how long you can use the mobile depends upon the battery capacity. And whenever you travel in the long time and long distance and you don't have charger, or you forgot to take your charger and there are no charging facilities in the vessel, you use it very sparingly, correct, to see important messages, or only you don't go through the movies. Okay, like that, the submarine batteries are very important because the diesel submarines will have to go to surface in the night times, and the whole day it'll have to remain underwater, mostly doing nothing. Underwater, you don't do nothing except using the sonars and other sensors. Okay, so preserving the battery is very, very important. And at times we even switch off the light and blowers if there is a requirement. Okay, we normally come up in the night times. Okay, maybe 3-4 hours we get. During that time we charge our batteries. This is a general layout of a propulsion system. We have got a diesel engine. The diesel engine runs a generator. Generator can give power to the electric motor which propel the submarine, or the same generator can give power to the batteries. It can do both simultaneously also. This is how a normal submarine works. Diesel electric submarine propulsion system works. And in case while underwater, okay, when you are in operation areas, you cannot come up to charge your batteries or receive signals and communicate messages to the headquarters, because the moment you come up, you may be forced to go down either by a bomb or by otherwise. Okay, so that time we do something called snorting. Snorting is the most important evolution because this diesel engine, maybe 2000 or 3000 horsepower engine, will be running underwater while we are snorting, but that is when we are just below that, and we will have good about 1 or 2 meters of head above the diesel exhaust outlet. Normally the diesel exhaust goes out when you are in surface at this level itself, but when we are doing snorting, it goes out from this. Okay, it's a most important difficult evolution, and you will have to, everybody on the submarine, including a cook and steward, will be on alert. He will be, in some near valves or near some equipment if there's an emergency to operate it. Even the doctors will be standing near a valve whenever we do snorting to operate, or some equipment to operate. Okay, so, and this snort mast, how do we, this is how we push the exhaust out. And how do we get the fresh air? Fresh air is received from the snort mast. Okay, this mast is it's a hydraulically operated mast. It goes up. It's a big opening of about 3/4 of a meter diameter, and through which air comes in and gives supply to the diesel engine. Diesel engine operates. In addition to that, we ventilate the complete space. 18-20 hours we are underwater whole day, good about 100 people or 70-80 people depending upon the size of the submarine, and they all will be doing what all they will be doing, and so much of gas will be gas and dangerous gases will be created. Air will be polluted, though those air will be pushed out because while taking in air, the diesel will suck the air from the compartments also. They all will be pushed out in form of the engine exhaust. And the most important thing we do in this position is transmitting and receiving signals. Encrypted messages will be sent and we will receive this. And that is done very sparingly, few minutes maybe, not much. And we raise the periscopes above the water level. Periscopes in the olden days, optronic masts now, they observe the surroundings. If required, we take sight from the constellations on top, or if there is any nearby land site, also we take references to see whether we are in the right place or not. This is called a snorting operation, in which we do the charging of the batteries, and we get just about 3-4 hours in a day. Very rarely we get, and we have to preserve the power the whole day. And next is nuclear powered propulsion. Okay, that you understand now. It's a big constraint running the diesel engines on surface, because you are most likely to, or you are likely to get caught when you are just underwater, because enemy is also as smart as us, and he may have ways to find out submarine even below, just below the water. Okay, so we need to remain underwater for longer time, for days and months. That is achieved by the nuclear powered propulsion. This is a reactor, and we get steam generator. From this we get steam to run the turbines or with the alternators. And advantages of this is that you got plenty of power and you don't have restrictions even underwater to use the power. That gives a lot of convenience, a lot of endurance. You can remain underwater, as good as 6 months. And the what is the endurance limit of a nuclear submarine is a human being. If a human being can remain underwater in that condition for 1 year, the submarine can remain underwater for 1 year. And we can carry enough food also, packed food and capsuled food and things like that. So human endurance is a limit for a nuclear submarine. And no navy has stayed underwater beyond 6 months of time. Otherwise the human will go mad. Okay, if you stay beyond that. Okay, and the nuclear submarines have got a lot of advantages, no doubt. But the nuclear submarines generate more noise. Noise is the biggest enemy for the submarine, because the enemy track or identify the submarine underwater with the noise they generate. Okay, so to overcome this, something called air propulsion system, which is not using a nuclear submarine or other nuclear reactors, or it doesn't use diesel engines which require fresh air. There could be closed circuit diesel engines can be used, or closed circuit steam engines, or fuel cell, and those type of devices are used to propel the air independent propulsion submarines. And this will have extremely low noise, and you are really very safe. With this submarine you can remain underwater for about 2 weeks, not unlike nuclear submarines. Okay, and underwater, when you are there for such a long time, how do you know where you are? Okay, when you are in surface, you got global positioning system, you got periscope, you can take land site as references, you can take the stars and moon as references, you will know where exactly or where approximately you are. But underwater, how do you do that? How do you know where you are? That is done by something called inertial guidance navigation system. This uses the inertial sensors. Inertial sensors are used in this, which include the accelerometer and gyroscope. Okay, using these devices, you keep tracking your movement on a map. Okay, you keep plotting, and that will tell you approximately, not approximately, exactly. But as the time goes, okay, there will be error. In any equipment, there will be error, and that happens, you get drifted. There's submarine, because we think we'll be going straight like this, say from east to west or from the south to north, but actually you may not be in the correct position, because the drift may carry you towards the right side or left side, or towards this side or that side. Okay, so this is called the drifting errors. You have to come up once in a while, even underwater, when you remain underwater, to take the references from the atmosphere, environment, either from a global positioning system or otherwise, to correct your map, which gives a location of you. Sometimes we use a sonar system also, if there is a known structure underwater at a particular place, or when you are at a particular place, as per the map, if the depth below the submarine is supposed to be 400 meters, and if it is not 400 meters, at least it will give an indication to you that you are not in the right place. Okay, and next, the other navigation systems are photonic mast. Photonic mast replace, these are all electronics. It's like a digital camera instead of sighting through this, and it has got a lot of automatic displays, and you don't have to stand difficultly, turn the periscopes and keep through the prism and optical mast. Okay, you don't have to strain yourself. You can sit comfortably in AC space, and through the monitors you can see what is happening on top, and they are all can be recorded. This is called photonic mass or photonic systems. Okay, and anyway, this can be done only when you are at snorting depth, just about 15-20 meters, sorry, 10 to 15 meters below the surface. And underwater, how do you communicate with the world, with the headquarters? That can be done only with a very low frequency radio. Okay, and even this very low frequency radio cannot reach very shallow waters. It will reach approximately about 76 meters. And I am very happy, you all may be knowing, but anyway, I am very happy to inform you that in 1990, there was a VLF station installed in Vijayanagaram, Vijayanaranam, which is in Trinelveli district. This tall tower shown in this is at tallest structure in India, standing at 471 meters. Not very many countries have very low frequency radio station, and very few countries, maybe 4-5 countries, and we are one of them. We can be proud about it. And this is covered, thousands of kilometers. So we help other countries also, friendly countries also, in communication. Since we have restriction of up to only about 76 meters, how do we communicate with a submarine which is below 76 meters or 100 meters or 200 meters? That is done by extremely low frequency radio. But these low frequency radio waves, stations or signals, have got restrictions, means you can send only very short messages as the bandwidth is very low. Normally, we use a very low frequency, extremely low frequency. Sorry, my mistake, it's extremely low frequency. Extremely low frequency signals just to tell the submarine down below, you come up, I'll have to tell you something. Okay, and that is done by extremely low frequency. And when he comes up 40-50 meters or 50-60 meters, we use very low frequency and communicate with them. And sometimes if he is in a restriction, okay, to come even to below 70 meters, above 70 meters, what he does is he uses the, wire antennas. He releases the wire antennas. Okay, it goes up at to a shallower depth and communication takes place. And underwater telephones are also used. Underwater telephones have very short ranges. Okay, it is acoustic signals are used. You can communicate with the adjacent vessels, and you also can communicate with the with the headquarters, a few kilometers range. This is used in civilian applications also. Oceanographers use this to control their robots. And next is sensors. What are the different sensors? That is for communication. Earlier we saw communication, and now we see sonars, sensors. One of the important sensor is sonar, sound navigation ranging devices. The sonars are the eye of the submarines. Okay, you don't see while going in a place. You use your sonar to see there is nothing on your way, and you travel with that. Okay, and also this will help you to detect any enemy object nearby. This can track where he is going, wherever he is moving, and he is in which area, which part of, is he off Visakhapatnam or he is off Chennai. Okay, that also can be localized. And from the type of sound he makes, we can make out whether it is a diesel submarine or it's a nuclear submarine or it is a surface ship, whatever it is. So these sonars are very effective. And sonars, we have active sonar and passive sonar. Okay, active sonar is, whether to see whether your son or grandson is studying or not. You make the noise and go into his room. Hey, why are you there? Okay, so you alert him. That is active sonar. The passive sonars is silently you go and see. Okay, that is what our submarines do. They don't make any noise. Okay, they don't send any waves, but they absorb the waves coming from the sound waves coming from the submarine, other enemy submarine or enemy object, from which he makes out. This principle of sonars are used, you may be knowing, by whales, dolphins, and bats also. Okay, and the passive sonar, it silently, as I told you, silently listen, it doesn't make noise. So normally we use active sonars and passive sonars, and we don't use active sonars. Only when it is unavoidable we use active sonars. And we use something called towed array sensors. Normally the sonar arrays are mounted on the pressure hull. Okay, that gives some restriction with regard to the depth and other thing. So, and the clarity is also, resolution also may not be good. So we have got something called towed away sonars. This is released from the submarine. It comes to lower depth, okay, shallow depth, and from this we receive or send sonar signals. This is called towed away sonars. Next, other type of sensors are called radar. Radar are used only when you are on surface. Radio waves are transmitted. That can be done only because radar don't travel underwater. Okay, we use these sensors on surface or when you are underwater, just about 10-15 meters range by raising the mast. This is the radar mast which is raised, and in the additional communication mast, okay, periscope and things like that. And radar mast is raised, we sight. Here also we detect an object, we track the object, and we image the object using the radio waves. But they are all high frequency, this thing, okay, for high frequency radio waves. Okay, we saw various mast and communication systems. They are all, dumped in the mass required to rise and lower them, or mass dumped in the or located in the fin. This is a fin area, as we have seen. You can see the 8 mast here, and the person who maintains it, not underwater, while on surface or on in the harbor. The life of a submariner is very difficult even in harbor. Okay, because you can see, you can see the location and how he has to maneuver through this area, and we have to maintain these equipments. Or even at sea, if there is a defect, you surface and see to identify the area of defect and nature of defect. You'll have to maneuver through this. You can't stand, you cannot sit. You at many places you may have to crawl and see these mass. Okay. Next important sensor is echo sounder. When you are at sea underwater, you should know what is your depth down below. And this helps you to know whether you are in right place or not. That is done by echo sounder, which again uses the sound waves. And this echo sounder also gives indirectly, approximately an indication where you are. As I told you earlier, if as per the map, if you're supposed to be in a location where the depth of the water below is only 100 meters and you find 4,000 meters as this echo sounder, something wrong, you have to correct yourself. And also, if there is an object, sunken ship or submarine, these echo sounders give an indication. These are the advantages of the echo sounder. Next most important thing is depth gauges. Okay, down below you may have any amount of water, any amount of depth, but you should be at the controlled depth. If you are supposed to be at 37 meters, you should be only at 37 meters. You should not be at 30 meters, or you should not be at 40 meters. Both are dangerous. If you are at instead of 37 meters, if you are at 20 meters, you lose the depth. And losing the depth means, coming to the surface only, because controlling, it takes time, reaction time is low, and it's likely that before you realize, you may come to the surface and you get sighted. Going underwater, the hydrostatic pressure is the enemy. So you should know the depth of water above you, or from the surface at what depth you operate. That is very, very important. That is done by depth gauges. There are different types, like a normal pressure gauge also, we have depth gauges. There are different types, and we use various types of depth gauges, so that, or even if a number of depth gauges at various places, and there will be so many watchkeepers watching it. It is not only from the control station, it will be watched from the aft ends, last compartment, it will be watched from the engine room, it will be watched even from your dining hall, because depth is a very, very important. Okay, and now we will come to weapons. Weapons, the weapon of a submarine should be swift, silent, and sure. And we have such weapons called torpedoes. It's a self-propelled weapon. It has got explosive warhead, and they can be launched either from underwater or from the above surface. And it's designed to detonate either on contact with an target or object, or in proximity to this. And these torpedoes propel with homing capabilities. And here I shown the location of the torpedo tubes. You can see the guys doing maintenance or operation standing in this place how difficult it is. Okay, and this shows the firing of the torpedoes from the underwater submarine. And these torpedoes have the homing capabilities. Homing capabilities is basically from the sound you can make out, sound of the object you can make out. Okay, I mean the torpedoes make out where is the object and where is it going to. So you can track the submarines. Sorry, the torpedoes can track the target, and this tracking also can be done uh, either using active homing or passive homing. Active homing is torpedo emit sound waves, and from the echo it understand where is it and how is it moving. In the passive, it is silent. It just peep through with the sound waves, with the sound waves coming from the target or from the enemy ship. Okay, this is better way of doing it, because torpedo also should not reveal its position. He can change his course. If the enemy sights the target torpedo coming towards it, he can alter the course and move away, or he can make it silent. The ship can change the position and make it silent and move slowly without making noise, so that you can escape from the fired torpedo. And we have missiles. Okay, missiles are most important ones because it has got fantastic firepower, and from the submarine, you can fire the missiles either from underwater or when you are in surface. This gives strategic advantage, because when you fire a missile, he doesn't know a missile is going to be fired now, so it will give a surprise. These missiles can be fired from a vertical launcher or from the submerged submarine also, and from underwater also. We can lay mines. Mines is nothing but detonators laid in the ground of the sea, which when get contacted with any object will explode. Okay, and this also can be done by the submarines. It can go underwater very silently as close as to the harbor and lay the mines. Okay, and these mines are laid from the torpedo tubes. And in all the slides, or most of the slides, I was talking about silence, stealth and things like that. What is stealth? Stealth is a technology. So stealth technology is something which makes a submarine silent. This is also called the low observable technology. Okay, it's a technique and design feature to reduce the detectability of an object. Okay, how do we do it? We minimize the reflection. Enemy radar or sonar, when it comes, it should not go back. How do we do it? Either by a hull design, which reduces the radar cross section area, and also we paste the rubber tiles, or called anechoic plating, which is as good as about 2 to 3 inches thickness all around the outer submarine of the outer periphery of the surface of the submarine. So this helps in two ways. One is, even our own noise generated get attenuated at this rubber tiles. We call them rubber tile generally, and anechoic plating scientifically. And the enemy noise, coming from, not noise, rays coming from the enemy, either it can be sonar or it can be radar, gets attenuated. It doesn't get radiated from this. This is it's like a thermal, audio insulations inside any chambers. Noise doesn't go out. Okay, or it put outside so that outside noise is not coming in. Okay, and also during the operation, we follow some disciplines. We don't transmit radar waves, we don't transmit infrared or acoustic signals unnecessarily, and when you do it, so also use very minimally. Okay, and you will not find, we don't go even one piece of solid material outside the submarine when we throw underwater. We don't pump out bilges when we remain in enemy water. We don't push out waste material from the submarine. We don't even blow our latrine, okay, when we are closer to the enemy area. Such disciplines are followed. Even if you do it, we go deep into the water, and there you release it. And while snorting also, you have seen the exhaust gases are released underwater at night times. Underwater, when you receive it, you cannot see, and even the infrared rays also cannot be detected by enemy aircraft. or enemy ship. Okay, and because it gets cooled by that time. And normally we are all well trained. There should not be any emergency, but an emergency is an emergency. It can happen, and it has happened earlier. So we have to be prepared for facing emergency situations. And underwater, the chances of emergencies are very, very, very manifold. Okay, and how do we do it? We have got our own surfacing capability. I mean, if there is an emergency, normally in normal evolutions, we come by following a procedure. We come up from a depth by following a procedure. It takes slightly longer time. We cut short the procedures. Okay, we do emergency procedures, implement emergency procedure, and come out fast if there is emergency surfacing procedure, and come up fast if you are underwater, if there is an emergency and underwater. That's one way of managing the emergency. And next one is, if the submarine is sunk, means it just cannot come up. If it reaches that situation, we come out of the submarine through the escape hatches or escape towers or through the torpedo tubes. Okay, and while doing so, we need to use special suits and special breathing apparatus, because coming from underwater immediately on top is very dangerous. It will have to be a controlled ascent. There's calculations. You have to go up 1 meter and wait, and things like that are there. Okay, otherwise there will be a decompression sickness comes in, and it can burst your lungs if you come up fast, uncontrolled. When you are escaping, wet escape, if you do, means you escape through escape hatches or conning towers and things like that. The next method is escape capsules or rescue spheres. These are all, some sort of domes or a mini submarine attached to a submarine, which can be assessed from the submarine. If there is an emergency and if the submarine cannot come up, okay, then we use these spheres, rescue spheres. All of us get into these spheres, and the sphere become a sort of mini submarine, and the sphere is released, it come up, and then our rescue team comes and relieves us. These are all escape capsules or rescue spheres, but not very many submarines use this, for the simple reason it will unnecessarily increase the load of the submarine, size of the submarine. Okay, and system requirements will increase. It will reduce your fighting capabilities. It will increase your escaping chances, escaping capabilities, but it will reduce the fighting capabilities. So it's not used widely, but there are submarines using this. Okay, next one is submarine rescue facility. What is this rescue facility? The same condition, that is, submarine cannot come up, and submarine sailors or the crew also cannot come up for some reasons. Okay, and they don't have escape space. In that condition, what do? We have to go from outside, from the headquarters or from outside. We have to go approach the submarines, and we have to help them out. It is like a baby stuck inside a well, okay, inside the tube bore well. So these people are to be taken out. That we use submarine rescue facilities. Olden days, we used to have rescue ships. Okay, rescue ships have its own limitations, and the technology those days also not much advanced. Okay, now we have got submarine rescue facilities. And what is a rescue facility? We will see the video that will clarify this. The video.
Submarine rescue is a difficult business. There are many unknowns and variables. Each submarine accident is different. The Dato submarine rescue system is unique. It's the world's largest flyaway transfer under pressure system. It consists of 3 different parts. Firstly, we have the intervention system, which is a remotely operated vehicle. The next piece of equipment we have is a rescue vehicle, which is a submarine that goes underneath the sea to rescue the people, and also a transfer under pressure system. We go down to the submarine, We then mate with the submarine. We drain the water down to make sure there's the hydrostatic pressure to hold the submarine on top of the disabled submarine. Once the hatch is opened, we can go inside the submarine. We can lift casualties out of the submarine and bring them into the rescue vehicle, unload the personnel into the transfer under pressure system where they can receive medical treatment. The NATO submarine rescue system has not been used for real yet, thankfully. However, the intervention system was used back in 2005 with the Russian submarine, the Prit, and we went down and it was able to cut the cables that were holding the submarine on the seabed, and we saved the lives of 7 Russian submariners.
And I am very happy to inform you, we also have acquired such a system, such a facility, and it is located in Visakhapatnam. Okay, it's a very composite system which can be transported by air to the nearest harbor and can be shifted to a ship, and from the ship it goes to the location, and from there we will be able to rescue the submariners who are stuck underwater. It's a very, very beautiful high technology system, and we are proud that we have that. And next we come, we said, life on board a submarine. There are certain aspects that affects the life on board. What are that? We will see. The cramped living quarters, which gives the claustrophobia and other things, and limited privacy. See here, you see this guy sleeping here. Okay, and like this, in this condition, he is there for 20-30 days. And this is a bigger submarine of about 10-meter diameter, and probably this is a nuclear submarine. In diesel-electric, I'm not getting pictures of the diesel-electric submarines. Okay, and what the diesel-electric submarines are generally 6-meter diameter, and there are bunks like this, and just adjacent, it's as small or as big as a railway bogies, railway compartments. But you have 3 bunks, and in between you will have so many equipments, unlike ships. Like this submarine, in the submarine where I have operated, the place where these guys are sleeping, on the left side of this place, there are 3 hydraulic motors. Hydraulic gives the lifeline to the submarine because they control almost all the equipments. The 3 hydraulic motors will be running 24 hours. In addition to that, there is a bilge pump just down below, and there are blowers. Okay, and there are small alternators. This all will be running, and these guys are expected to sleep in this. So life is very difficult in that conditions, and you don't have much privacy. 20-30 days you'll have to keep seeing these faces only. Okay, and you'll have to change the dress, whatever you want to do. If you have to scratch your head or some other secret places also, it will be difficult for you to scratch. Okay, so in this condition, sailors and we live for such a long time. No private, limited privacy. No privacy there, and it's very difficult. You have to work in that submarine, and there are challenges in maintenance also. Like as I said, there are 3 hydraulic pumps running behind, and there are some reducers, safety devices. If there is any problem there, these guys' sleep will be disturbed, and the watchkeeper who goes, and the mechanic who goes and repairs them, or the officers who goes for inspection, they'll have to literally crawl through this space and go into that place and rectify them. These are the maintenance challenges we have on board diesel electric submarines. And we know the most important place for us is where we read newspapers and other things is the toilets. These are the typical toilets in the submarine. Okay, and this is in the advanced submarine, and you can imagine how they could be in old submarines which are operated by in our generation. Okay, and very cramped place, and there are no privacy also. And in addition to that, when you are doing your own operation, you will be told to operate something else also. Like we may be told to open this valve, we may be told to operate this reducers. Okay, those type of situation, and you may be told to see the pressure and inform them through the opening. We will be asked. Okay, so these are the difficulties. And next one is you can't walk straight inside the submarine. There will be hatches, pressure bulkheads. Okay, pressure tight bulkheads, and there will be hatches like this. circular hatches, and you will have to, sort of swim through the hatch if you have to go from one compartment to another compartment. If you're going for a jolly walk, it's okay, you can go like this. But if you're carrying some important documents, important tools, okay, along with you, you can imagine how you will cross this location. The most important thing is, unfortunately, the younger sailors, junior sailors, okay, they don't have a dining hall in the diesel-electric submarines. They'll be having a plate with some rice and curry and all those things. And in one hand, you will have a set of buttermilk, and we will have to maneuver through these openings. And it's really difficult to do that. There will be submarine, maybe, say, sailing at high speeds. These hatches are normally in all conditions, they are left closed. You have to come to that location, open the hatch, cross the area, come to the other compartment, and then close the hatch again. If you are lucky enough, if you have somebody nearby, they will help you out. Otherwise, it's really a big thrill or juggling thrill for you. And these are the machinery layout inside a submarine. And incidentally, this is a sort of modern submarine. You can see the cramping of the equipments and other things living here. And this doesn't show all the rations required, the rice bags and atta and vegetables. That vegetables are kept in the cold room, but other dry items which we carry are left here and there. And 100 chaps, all of them will carry at least one small briefcase and one small airbag. They all to be dumped. Okay, and they're changing clothes. Okay, for 75 people or 100 people, every 3 days the dress is changed. We call it as disposable dresses. Okay, why we use disposable dresses is you cannot carry large numbers, and other thing is we will come to it a little later. And noise, all the noise these things create also, you have to bear it. And this is a typical location. This is a submarine museum. That's why you find this type of figures sitting there. And this is a top door space, which we have seen earlier also in some place. And you have, in this place itself, you have got decks. You have got so many equipments. And you see a hydraulic machine going behind, and there are some valves above, and same type of arrangements down below. Well, operation or maintenance, you have to reach this place. And there some guy maybe, sleeping in this area. You have to disturb his sleep and approach this place and operate this. These are the maintenance challenges. And when it happens during evolutions like torpedo firing and things like that, it will be a great task for us. And this is a typical engine room. This engine room picture also taken in during a construction or repair phase after it is completed. Because while we are sailing, you will find, cupboards hanging here with, all our documents. Will have a document rack here, and we will have special ration, and we will have emergency freshwater tank, and we will have emergency containers hanging around here. It's okay on top, it looks spacious, but imagine the space below this area at the bottom of the diesel engines, 2 diesel engines on both sides, and there will be one on the other side. They will be 1,500 to 3,000, 4,000 horsepower diesel engines running, and you have to go down to carry out an inspection, or you have to go down to do some defect repair. Impossible. The persons who have done the most serious crimes or sins in the last birth, are born in this birth, and they are made submariners, and they do this job. Okay, it's such a horrible hell of a situation inside the engine room below the deck. You can see, the layout of the equipments in various places. The same type of situation. This is an engine control room. Those days, not much of automations, and most of them are manually done, and you have to keep watching all these parameters, okay, continuously, because anything can go wrong anytime. So it's a very strenuous job, and it's a very tense job. Life is very tense when you're on watch. You work good about 3 watches. The 3 watch system we follow means 4 hours we work, 8 hours we take rest, and then 4 hours. And in that 8 hours in between, it is not only for sleeping, it is for our bath, it's for our eating, it's for our entertainment. And if there is an operation, okay, you remain awake. So In my case, personal case, I remember there's an occasion in which I was awake doing an important evolution of diving and submarine and snorting and things like that for 36, 40 hours continuously. I didn't move out of this place. Okay, so uh, uh, operation is very difficult. Maintenance is also very big. This is from a sort of decommissioned submarine. Many equipments are removed from this place, or at least the watchkeepers. There will be in this place, what you see in this picture, there will be a watchkeeper operating this. There will be a watchkeeper who will be operating diving and surfacing procedures. There will be an operator there who will be operating this radar, and there will be a control room watchkeeper standing here, and there will be an officer controlling all their movements. This is how a submarine is manned during an operation time, normal operation time. And if it is an emergency operate time, beyond them, all watchkeepers, all three watchkeepers will close here, and you will have to push chaps here and there, and you reach the place or reach the equipment to do this job. Anyway, it's not difficult, and we do it. This is another place, cramped place, and there will be good about 7-8 watchkeepers doing their job in this area. Okay, and fresh water. And we were talking about, we were talking about these toilets. I wanted to tell you, in a submarine where about 80 to 100 personnel sail, there will be only 2 toilets, 2 WCs, water closets. Okay, and this you can imagine, even in our house where there are only 4-5 people, there will be 2 toilets. Even in that, we land up in some emergency situations. We go to the first floor, or we go, we curse people, shout at people, make them come out. And there are 100 people, 2 toilets. You can imagine what type of situation may come up, and we get used to that. And also, these toilets cannot be flushed through. I mean, the waste cannot be sent out of the cement as and when you like. Okay, depending upon the depth, depending upon the situation on top, depending upon the sunlight or the light under night times. Normally we do it under deep underwater, and when we do it underwater, you open the submarine to a higher hydrostatic pressure. You allow the seawater pressure, and you'll have to be very carefully needed. Even for blowing the wasted tanks, you need high skilled, and you need so much of you should have so much of system knowledge, and you should be very prompt and correct in doing that. Okay, stress everywhere is stress. Now we'll talk about freshwater. The most important challenge in a piezoelectric submarine is water. Say, for example, a submarine with about 75 personnel. It will have a capacity, 40-ton capacity freshwater tanks. Okay, you can carry from the harbor 40 tons. And unfortunately, those days, even in 70s and 80s, we were operating. We didn't have good RO systems to generate water at sea, and generating water at sea is those days compromising on your fighting capabilities. So we don't generate water at sea, and we go out with 40 tons. Assume a condition in which the submarine will have to be at sea for 25 days, 75 personnel. If you calculate it, one person will get 21 liters of water. And this 21 liters is just not all for him. This 21 liters is used for cooking food for him, one, and to operate various machineries like diesel engine is a freshwater cooled system. And the gyroscope is a freshwater cooled systems. And we may have to top up some other important areas also. Distilled water is cooled by fresh water. Okay, so with 21 liters, he has to use it to meet all his personal purposes. You'll have to cook food. He doesn't cook, the cook cooks for him. And that is the most difficult job. Another most difficult job, because 2 cooks will be there, and you'll have to cook for 100 people or 75 people in that cramped condition. And also he will have to do some operations, okay, some watchkeeping when there is an emergency, not emergency, when the operational requirement, when you are in enemy water. Okay, with 21 liters, you have to do all these things, and you come to how much water you will get for yourself. You believe it or not, I am the in charge for the freshwater tanks because I'm the engine officer or any engine officer, even the commanding officer or the executive officer. Okay, the top 3 important people on the submarine and the electrical officers. They also get just about 2 liters of water for their personal use. With that, what they do, they wash their face or they brush their teeth or clean some places and in their body that's it is left to him. But only this much water he gets, and this is how we sail for 25 days. And even if we fail for shorter days, the luxury is not given because once you get used to the luxury and you will always demand it. Okay, so and it is not possible technologically those days. So a man gets 2 liters of water. I used to get 2 liters of water every day whenever I'm at sea. We are not permitted to shave. We are not permitted to take bath. Inside the bathroom, whatever else we can do, we can do. So fresh water is the biggest challenge, which gives the biggest challenge for life on board. Next one is air. We don't, and when we are underwater for 18 hours, 100 people inside the cylinder for 18 hours. It's not just them. In addition to that, there are a lot of gas emitting operations. There are oil and diesel fumes everywhere. The galley smell comes out, and when you dive last time, some exhaust gases are left out in the submarine. You can't push out. Those exhaust gases get spread, and you get CO, carbon monoxide, carbon dioxide. Above all, other hydrogen which gets evolved from the submarine. There are submarine batteries, okay, which cannot be avoided. They all get accumulated and the air just become horrible. There are methods of purifying this air. We do it a little bit. We filter them, we purify. But whatever it is, a polluted air is a polluted air, whatever operation you do. We don't generate oxygen, of course, in a big way in the conventional submarines, whereas it happens because the nuclear if it happens in the nuclear submarine, submarines will have to remain for months underwater. So that's that's psychological stresses of isolation, monotony, and potential threat of detection by enemy forces. These are the stresses we face. Okay, and to ensure that we have got solid training and drill, very rigorous, because the Navy believes that you sweat, or defense forces believe you sweat more in peace, you bleed less in war. So we sweat more in peace, and our life is difficult always, whether it's a peacetime or wartime, and it's more so even in harbor because maintenance is very difficult and underwater hazards are too much. Okay, now we'll come back to now probably understand better what Churchill said, that the submarine faces grimmer perils, okay, of all the forces. Of course, he also says he's more devotion. He shows more devotion, and if we don't show more devotion to our duty, if you are not more responsible, we will not be coming back to harbor because the demand is such that. Of course, the advances in submarine technology over the years have improvement in accommodation, safety, overall living conditions. We can carry more fresh water. We can generate fresh water. Okay, but the other problem is you've got radiation hazards. You have to remain underwater for longer time, months together. You will be away from your family for longer time, and you can't even say hello to hi message to them. Okay, they're the side by side hazards which come in, difficulties that's coming in. So with this, I'll finish it. I'm sorry if I taken slightly longer time, and if you have any questions, you may please come up.
PPT can be closed. Stop
Meeting
sharing.
can be no questions, sir.
Well,
Chinaya,
stop
yes.
sharing.
one Mr. Ramakrishnan is a mariner, 96 batch. He has asked one question: how to the emergency response for the blackout time?
Emergency responses, we have got
PPT is stop now. Stop share.
Sorry, sir, I couldn't help you. I couldn't get you.
Stop share. Just click stop share. Screen share can be stopped.
Oh, screensaver can be stopped. I'll come to it, sir. 1 second. Before that, I wanted to use this some more after the questions. Anyway. Yes, sir. Yeah, emergency response. Every time we face emergencies, we are to face emergencies, and we are always ready. There are always drills to face any emergency, including a fire, including power failure, including an explosion, including a flooding. Okay, these are all we continuously have drills and standby methods. If one pump fails, we have got standby pumps and things like that. This is how we face emergencies.
Is it a possibility for implosion, gushing of water into the submarine?
Yeah, we can touch water. That's called stop trim or bottoming. We go down, and that we do when we have to. Literally, we don't have any power, and we cannot come up because there's guys on top with the bombs in the aircrafts. We go down. We bottom the submarine where we don't use any power. But it's a very risky operation because there will be underwater currents which may carry you to other locations, and there could be obstacles on the way. But we do bottoming. We also do something called a stop trim. Stop trim is basically no movements of the submarine. Submarine will be just hanging around in one place, but it will not move. Just we maintain minimum speed. Okay, minimum speed to keep it in its position. That's all. We call it a stop trim.
Commander, thank you for the detailed explanation.
Yeah.
I have few questions. How do you can go, number one? Number two, when you are inside, how you people manage oxygen? Because there will be circulation of air. I mean, you can't get outside air. That is number two. Number three, for some of the critical machinery like engines and motors, do you have a redundancy?
Yeah, the third question, yes, every equipment, especially the submarine, Russian submarines have redundancy. Okay, like we have 3 diesels, and even if one fails, we can manage. Even if 2 fails, we can manage. And anyway, except major defects, we are trained to carry out repairs at sea, at underwater. Okay, we do repairs and maintain. Most of the equipments we maintain. Very rarely, things come up that we will not be able to repair an equipment, especially the external devices. When they fail, we cannot. Okay. Like sometimes even the planes get stuck, they don't operate. Those type of defects we cannot, but most of the defects we do. And the second one is, air underwater is really a big challenge. We can generate oxygen, but we avoid because it's a very hard process. We burn the oxygen regenerators and